Welcome to David Alexander Maths Tuition. This is chapter 7b on using the angle addition formulae. Okay, so in chapter 7b, these are some of the questions you might see. In an actual exam, you'd never see this because first of all, you'd always have access to a calculator. So the cos of 75, we could write that as the cos of the 74 plus 1, because 74 plus 1 is 75. But if I do my addition formula, I don't know what the cos of 74 is and I don't know what the cos of 1 is, so that would be fairly pointless. But if I can turn it into, let's say, the cos of 45 plus 30, I do know what the cos of 45 is and the cos of 30. So let's use our addition formula. So that is going to be cos 45 cos 30 take away sine 45 sine 30. So I'm just going to think about my triangles. So here is my 1, 2, root 3. So this is my 30-degree angle here. And the other triangle we can draw is 1, 1, root 2. Again, you don't really need these triangles because you can do them using a calculator. Right, so the cos of 45, here's my 45-degree angle here. That is 1 over root 2. So that's 1 over root 2 multiplied by the cos of 30, which is root 3 over 2. Take away the sine of 45, which is also 1 over root 2, and the sine of 30 is 1/2. So what we get is a root 3 over 2 root 2, take away 1 over 2 root 2, in other words, root 3 minus 1 over 2 root 2, and by rationalising the denominator we can turn it into root 6, take away root 2, all over 4. So that is the exact value of the cos of 75. What about the sine of 15? Well, the sine of 15, I can say that that is the sine of 45 take away 30. So that is sine 45 cos 30 take away cos 45 sine 30. Now the cos of 45 and the sine of 45 is 1 over root 2, which we had in the previous question. So let's just think about that other triangle again. 1, 2, root 3. I do like using these triangles, but of course you don't need to know them because you can use the calculator every time. So this is my 30 degrees here. So the cos of 30 is root 3 over 2. And the sine of 30 is 1/2. So what I have here is root 3 over 2 root 2, take away 1 over 2 root 2, in other words, root 3 minus 1 over 2 root 2, and rationalising the denominator by multiplying top and bottom by root 2, I get root 6 minus root 2 all over 4. So that is the exact value of the sine of 15. Okay, so for the tan of 75, we can say that that is the tan of 45 plus 30. So that's going to be tan 45 plus tan 30 divided by 1 minus tan 45 tan 30. Now it's handy to remember that the tan of 45 is simply 1. So that's going to be 1 plus tan 30 over 1 minus tan 30. So what is the tan of 30? So here's my triangle, 1, 2, root 3. So here's my 30-degree angle. So it's 1 over root 3. So it's 1 plus 1 over root 3 over 1 minus 1 over root 3. So that is the exact value of tan of 75. However, you might want to tidy this up a little bit. Can we get a slightly better answer? It's 1 plus root 3 over 3 over 1 minus root 3 over 3. So let's again just tidy up the top and the bottom. So that's going to be 3 plus root 3 over 3 divided by, I'll just write a division sign here, 3 minus root 3 over 3. So that is 3 plus root 3 over 3 multiplied by 3 over 3 take away root 3. The 3's cancel. So that is 3 plus root 3 over 3 take away root 3. So let's multiply the top and the bottom by 3 plus root 3, 3 plus root 3. So on the top, we're going to get 9 plus 6 root 3 plus another 3. So that's 12 plus 6 root 3 on top. And on the bottom, 9 minus 3, which is 6. Divide through by 6, so that is 2 plus root 3. So 2 plus root 3, that is the exact value of tan 75. Which you can check on your calculator, but of course if you're using a calculator you probably wouldn't do all this unnecessary working out, you just whack it into your calculator and get 2 plus root 3. But it's good to know that you know these angles can be split into angles where we can use these addition formulae. Without using your calculator, find the exact value of sine 60 cos 30 plus cos 60 sine 30. So hopefully we know that this is the sine of 60 plus 30. So that is the sine of 90. So let's just think about our sine curve. There's 360, there's 180, there's 90, and that is the maximum. So that is simply 1. Second one, cos 70 cos 20 minus cos 70, sorry, sine 70 sine 20. So because it's a minus, that means this is going to be the cos of 70 plus 20. So that is the cos of 90. So let's think of our cos curve. So there's 360, there's 180, here's 90. So the cos of 90 is 0. So all this stuff here equals 0. Okay, so here we've got a plus sign, so this is going to be the cos of 130 take away 40, which is the cos of 90, which, as we previously established, that is also 0. Okay, so here are a couple more examples. So here we've got tan 40 plus tan 20 over 1 minus tan 40 tan 20. So we need to recognise that this is the tan of 40 plus 20. So this is the tan of 60. Now the tan of 60, let's just draw out my triangle. 1, 2, root 3. Here's my 60-degree angle. So it's root 3 over 1, so that is simply root 3. That is the exact value of all this stuff here. Okay, so this is a slightly nasty one because it's in radians. We've got the plus sign here, so this is going to be the cos of 5 pi over 6. Let's just write this out. Cos of 5 pi over 6 take away 2 pi over 3. Now 2 pi over 3, that is the same as 4 over 6. And 5 pi over 6 minus 4 pi over 6 is the cos of pi over 6. So let's think of our triangle again. So 1, 2, root 3. This is the pi over 6. Hopefully you're getting to the stage where you're thinking just in radians and not thinking, oh, pi over 6, that's 30 degrees. So the cos of pi over 6 is root 3 over 2. There we go. Express tan 105 in terms of tan 60 and tan 45. Well, we know that the tan of 105 is the tan of 60 plus 45. So we can write that as tan 60 plus tan 45 all over 1 minus tan 60 tan 45, just using the addition formula. So that is the first part done. So we need to show that this is negative 2 minus root 3. So the tan of 45 is nice, it's always 1. So, so tan 60 plus 1 over 1 minus tan 60 multiplied by 1, in other words 1 minus tan 60. So what is the tan of 60? Here's my triangle, 1, 2, root 3. Here's my 60-degree angle, so the tan of 60 is root 3 over 1, so root 3. So that is root 3 plus 1 over 1 take away root 3. Not quite there yet. Let's rationalise the denominator by multiplying top and bottom by 1 plus root 3. So on the top, we're going to get root 3 plus 1 plus 3. So plus another root 3. So that is 2 root 3 plus 4 on the top. And on the bottom, that's going to be 1 take away 3, which is negative 2. Okay, so I can divide through by negative 2. So that's going to give me negative root 3 minus 2. And that is, of course, the same as minus 2 minus the square root of 3, as required. Okay, so now we're getting into a slightly more tricky type of question. So we've been told that the sine of A is 3 over 5. So I'm going to draw a triangle. So if this is angle A, then the sine of A is opposite, which is 3, over the hypotenuse, which is 5. So this missing side is going to be the square root of 5 squared minus 3 squared, which is 4. Now, if the sine of B is 1/3, then if this is angle B, then the opposite is 1, the hypotenuse is 3, so therefore the missing side is the square root of 3 squared, take away 1 squared, and that is 2 root 2. Okay, now sine A plus B we know is sine A cos B plus cos A sine B. Now the sine of A is 3 over 5, multiplied by the cos of B, which is 2 root 2 over 3, plus the cos of A, which is 4/5, multiplied by the sine of B, which is 1/3. There we go. Perfect. So it does say A and B are both acute angles. So if we refer back to our cast diagram, as they're acute, that means they must be between 0 and 90 degrees. So all the trig functions are always positive in that quadrant. So we don't need to worry about minus signs here. So sine A cos B is 3/5 times 2 root 2 over 3. In other words, that is 2 root 2 over 5 plus 4/5 times 1/3. That is going to be 4 over 15. So if I turn this into 15ths, multiply the top and the bottom by 3, that is going to be 6. So that is 6 root 2 plus 4 all over 15. Okay, so this is a challenging question here. What we need to remember is that tan is is 1 over cot, or cot is 1 over tan. So if the cot of A is 1 over 5, then the tan of A is 5 over 1. Now I can do the same thing with the addition formula here. So the tan of A plus B is tan A plus tan B over 1 minus tan A tan B. So therefore the cot of A plus B is all of this flipped, so 1 minus tan A tan B over tan A plus tan B. Now we've already worked out that tan A is 5, so that's going to be 1 minus 5 tan B over 5 plus tan B. Now we've been told that the cot of A plus B equals 6, so therefore this stuff here equals 6. So 1 minus 5 tan B over 5 plus tan B equals 6, and multiplying through by 5 plus tan B gives me 1 minus 5 tan B is 6 lots of 5, which is 30, plus 6 lots of tan B, which is 6 tan B. I'm going to subtract 30 from both sides, so minus 29 equals, and I'm going to add 5 tan B to both sides, is 11 tan B. So therefore negative 29 over 11 is 1 tan B. So therefore the cot of B is just this flipped. So the cot of B is minus 11 over 29. Okay, so this is quite a challenging question to finish off with. So the cos of A is minus 5 over 8. So I'm going to draw a right angled triangle. So if this is angle A, then this must be 5 and this must be 8. So therefore I can work out this missing side length here, which is the square root of 8 squared take away 5 squared, which is root 39. Now, if the cos of A is 5 over 8, then the tan of A is going to be root 39 over 5. Now, the key thing here is that it's an obtuse angle. And of course, I've just ignored the fact that when I drew the triangle, I didn't write negative 5. It doesn't make sense to draw a triangle with a negative side length. So on my cast diagram, we can see that it's an obtuse angle is between 90 and 180 degrees. And sine is the only function that is positive between 90 and 180. Cos is negative, hence the minus 5 over 8. And tan is negative as well. So it's not root 39 over 5, it's negative root 39 over 5. For this next example, cos of 3 pi plus A, we're going to write this as the cos of 3 pi cos A minus the sine of 3 pi sine A. Now the sine of 0, pi, 2 pi, 3 pi, 4 pi, any multiple of pi is 0. So 0 lots of sine A is 0. So we can just ignore all of that because that is 0. Now, what is the cos of 3 pi? Okay, so here is, we know that this is 2 pi, this is 1 pi, so therefore this is 3 pi here. So the cos of 3 pi is -1. So it's -1 times the cos of A, which is -5/8. So the answer is therefore +5/8. Okay, now for this final example, well, I'm going to use my addition formula. So that is going to be the sine of 2 pi over 3 times by cos A minus the cos of 2 pi over 3 sine A. Okay, now the sine of 2 pi over 3 is root 3 over 2. So that is root 3 over 2 multiplied by cos A, which we know is -5/18. And we're going to subtract the cos of 2 pi over 3, which is -1/2. So I'll put -1/2 multiplied by the sine of A. Now the sine of A is root 39/8, or is it? Remember, we need to be thinking about the cast diagram here. Now in this, if the cos of A is negative, because it's an obtuse angle, if this is an obtuse angle, okay, my triangle's not drawn so that it is an obtuse angle, doesn't matter though, but I know that sine must be positive, so it's going to be positive root 39/8. Okay, so what I have here, I'm kind of running out of space, so if I just go over here, I might be able to sneak it in. So that is -5 root 3/16. This is going to be negative, so and what's inside the brackets will be negative, so I'm going to be minusing a negative, so that will be a positive, and that's going to be root 39/16. So an easier way to write that is just root 39 minus 5 root 3 all over 16. Sorry that's not massively clear, running a little bit low on space there. So the key to unlock these questions is do your little triangles, think about your cast diagram so you don't get the signs wrong, and also do your addition, use your knowledge of the addition formula as well.